Welcome to aminacademy.com. In mathematical formulae and their explanation, let us discuss about formula for higher derivatives. What is higher derivatives? The derivative dy by dx is more expressly called the first derivative of y. By differentiating the first derivative, we obtain the second derivative. By differentiating the second derivative, we obtain the third derivative and so on. These second and subsequent derivatives are also known as higher derivatives. Now, first derivative for y equal dy by dx. Second can be expressed d square y over dx square. Further, this is second derivative is d by dx of dy by dx, which is equal second derivative. We can represent this as f2 dash of x or y2 dash. Here f dash of x we can say, and we can say and y dash. Third derivative is d by dx of d square y by dx square, that is equal d cube y over dx cube. Then further we can say f dash of f3 dash of x, or can say y3 dash. Further, nth derivative we can represent in generally d by dx of d or n minus 1x over this y over d by n minus 1 of x. This we can represent it is as f power nx or y power n. Further, this we can represent d ny over dx for n. Further, it can be represented f for nx, or further f for n. Next, for example, let one do an example here. Y equal 3x plus 5 over 4. Then first y dash equal 4 into 3x plus 5 into 3x differentiation is 3, which is equal 12 3x plus 5 power 3. Then y2 dash means we have to differentiate this, that is d by dx of 12 3x plus 5 over 3, which is equal, this 12 come out of differentiation, and differentiation of this one is 3 into 3x plus 5 the square into differentiation of 3x is 3, which is 3 into 12 is 36, 36 into 3 is 108, 108 into 3x plus 5 over 2. Then it's continue for y3 dash means we have to differentiate this with respect to x and multiply with 108. It's continuous like. Now next, Leibniz rule for higher derivative of products. Leibniz rule generalizes the product of rule of differentiation. The Leibniz rule states that if two functions f of x and g of x are differentiable n times individually, then their product f of x into g of x is also differentiable in n times. For example, suppose the function y power n plus 1, that is n plus 1 times the differentiation, is u, first function differentiation of u n plus 1 v power 0, then plus sigma m to 1 to n plus 1 c m, and u of n plus 1 minus m v of m plus u of 0 v of n plus 1. And generally you can say, remember this, sigma m equals 0 to n plus 1, n plus 1 c combination m into u n plus 1 minus m into v m. Then from this we can second derivative d square y over dx square can be d square y of d square over dx square of uv equal q times d square v by dx square plus 2 du over dx into dv over dx plus v times d square y over dx square. And similarly d cube over dx square uv equal here cubic, so u into d cube v over dx cube plus 3 into du over dx into d square v over dx square plus 3 into this is square first, then d square u over dx square into dv by dx plus v into d cube u over dx cube. These are cubic, like it's expandable. For example, let's do an example for this function. Let y equal y equal 4x plus 3 power 4 into 2x minus 5 cubic. We have to find first y dash. We have to find directly this y is given. We have to find d square y by dx square. Y2 dash we need, that is equal, formula is d square y over d square of x square of uv equal, let us write here, u dv by dx u d square by dx square plus 2 times du by dx into dv by dx plus v into d square y by dx square. So first for this we have to find d square, first du by dx, first du by dx. Du by dx is, this is u, this is v. Du by dx is 4 times 4x plus 3 into 3 into 4, which is equal 16 4x plus 3 cubed. This is a du by dx. Then d square u by dx square is this differentiation one more time, that is 16 into 3 into 4x plus 3 square, which is into 4, which is equal 16 into 3 is 48, 48 into 4, 192, 192 into 4x plus 3 per 2. Like that, we have to find du by dx and dv by dx. We find dv by dx equal, here dv by dx, this is v equal 2x minus cube, 2x minus 5 whole cube, that is 3 into 2x minus v square, because cubic here, this is square, and derivative of 2x is 2, which is equal 6 times 2x minus 5 the square, d square v by dx square equal 6 into 2 times, because here 6 into 2 times 2x minus 5, that 1 into 2x derivative is 2, which is equal 24, 2x minus 5. Now look at here, this all we have to substitute in this. Therefore, here the second derivative you are finding. Second derivative we are finding this. Then second derivatives you have to apply u d square u. What is u? Which is equal. So now we have to find d square y by dx square. For this we have to find, then we have to apply this u. What is the function u? U is 4x plus 3 power 4, 4x plus 3, 4x plus 3 power 4, that is u. Then d square v by dx square, d square v by dx square is 24 2x minus 5, 24 2x minus 5, then 2x minus 5, write 5 clear, then here 2 into du by dx, du by dx, 2 into 16, du by dx is 16 4x plus 3 cube. Let apply this u d square v by dx square, u d square v by dx is 24 minus x cube, then plus 2 times 2 times du by dx dv by dx. Du by dx is 16 4x plus 3 whole cube, 16 4x plus 3 whole cube, 4x plus 3 4x plus 3 whole cube, and dv by dx is 6 into 2x minus 5. 6 into 2x minus 5. Then plus the last term v d squared y by dx squared. V is 2x minus 5 2x minus 5 whole cube, that is v into d square y by dx square, d square u by dx square. D square u by dx square is 192 4x plus 3. 192 4x plus 3 power 2. After simplifying, this becomes d square y by dx square. It's a lengthy process. If the powers are more, d cube by y by dx cube is still it becomes lengthy. Then you have to understand the concept. So far we discussed about higher derivatives, what is higher derivatives, and Leibniz theorem for higher derivatives. We have done. Please subscribe our YouTube channel.